Good afternoon, everybody. My name is Rich Peterson. I'm with SanDisk, and joining me today is Sergey Schatz, who with us is the technical side of the conversation, so you'll be spending most of your time actually talking with Sergey. But what I'd like to do in the beginning here is introduce you a little bit to who SanDisk is. I think you know who SanDisk is, but you might not know the enterprise side of SanDisk, what they've been building through their acquisitions of companies like FlashSoft. And so we'll focus today's conversation completely on the FlashSoft technology. Sergey is the engineering fellow at the Software Solutions Group within the storage business unit of SanDisk, and I'm the director of marketing for that same organization. My background is a number of different startups. Sergey was previously with Veritas and Quantum, among other companies. Sergey was the CTO of FlashSoft, and I was the former vice president of marketing at FlashSoft. So we both helped bring the company up to the point where it became a part of SanDisk in February of last year. One of the things I learned when we joined SanDisk was that every presentation has this slide in it. You've probably seen these before. Many of you may have been in my shoes in the past, having to explain what a forward-looking statement is. I'm assuming you all know what it is and know how to read, so I won't read it out loud. But today's agenda, we'll talk a little bit about SanDisk, where the company is going, why it's so interested in the enterprise space, what FlashSoft's role is as a part of SanDisk. We'll go through the technology itself, the product that's in production use today, some customer use cases. Sergey will take over, dive into the core caching technology. We'll talk primarily about FlashSoft for VMware vSphere. Talk a little bit about some of the performance reports, and then have some time for offline conversation. So there were a few things that I learned about SanDisk when we were acquired. Among other things, according to people that do this kind of thing for a living, it has the fourth most powerful patent portfolio, I think just ahead of Qualcomm and just behind Google. So it's a company that spent 25 years in the development of flash technology, focusing really on flash technology, pioneering primarily, of course, on the hardware side, the fabrication of NAND flash up through consumer flash, and today, enterprise SSDs as well. Sergey and I, of course, are interested in software that enables people to do interesting things with those flash devices, and that's what we're going to focus on in today's conversation. But we are a Fortune 500 company with greater than $5 billion in revenues. So when we say we're going to do something, we usually end up doing it. So the Software Solutions Group in the storage business unit, as I mentioned, is really about maximizing the value that flash can deliver to the data center, because we miss it. What a lot of people sometimes misunderstand about flash is based on experience in maybe replacing a spinning disk in a laptop with a solid-state device. There's this assumption that, well, flash is really just a faster spinning disk for the enterprise. And in fact, in the data center, there are many different ways to use flash that are more efficient than that, that deliver greater value than that. And that's really what we're exploring with our software solutions. We're exploring ways to use flash, obviously, in caching for storage solutions, using flash to extend the system memory for in-memory computing applications, and other uses of flash as well. So it's a broad view of how flash can be used more efficiently and more effectively as a resource in the data center. That's the mission of the Software Solutions Group. So I won't read the entire thing, but one of the key things that we are going to come back to on a number of occasions here is we believe that the use of flash technology is not just a performance enhancement technology, but it's actually a technology that delivers value so that we can actually reduce unnecessary storage spending and increase the efficiency of the data center through the use of flash technology. And so we'll spend a little bit of time talking about that, because we think that flash will go mainstream as an enterprise technology for storage once we can say not only that it improves value in terms of business application performance, but also in terms of overall data center CapEx and OpEx efficiency. And that's a big part of why we're doing what we're doing. Now, one thing that's very important too about the Software Solutions Group, SanDisk as a company is vertically integrated, which means from, basically from the SAN to the software, we're involved in the delivery of flash to the enterprise. But one of the things is that we do not have rules against doing business with people at one level, even if we compete with them at a different level. So we were talking earlier about Marvell, which delivers solutions that compete at the enterprise level, but actually the NAND flash inside those products is sold to them by SanDisk. And similarly, when we talk about our software is developed to support any vendor's solid-state technology. So it's not locked into the SanDisk hardware platform. And that's one of the key things about the software is the software solution is an all-software solution that is not tied to any specific hardware platform. And we'll talk a little bit about some of our partnerships in the course of this conversation today. We're also designed with an idea toward openness with respect to any vendor's server, storage, and network infrastructure. Recently, we've heard a lot of announcements about people trying to expand what they do in terms of moving from a storage technology vendor into becoming a storage systems vendor. SanDisk is a storage technology vendor, okay? We are not actively competing in making those kinds of extensions into competing against our closest partners at this time. And most importantly, our mission is really to drive new opportunities for the adoption of flash memory. So having given you the sort of speech, we'll talk a little bit about FlashSoft. So we all know how flash got into the data center in the first place. It started out inside storage systems as a fastest tier above a tiered storage system. And what we've seen recently, of course, is the all-flash array in the data center as a replacement, in many cases, for spinning disks. And what everybody's talking about now is how do we get the flash right into the server, adjacent to the CPU, where it can deliver the greatest efficiency in its IOPS, where it can be used as a cache that's still going to be open to underlying storage systems. One of the key issues for us is that we believe that this technology will be adopted incrementally, so it's both a revolutionary technology, but it's also an evolutionary technology. So our customers insist that we not interfere with existing storage systems, storage policies, storage practices. And the folks at Gartner tend to agree that flash can be implemented at multiple places in the server storage architecture, not necessarily mutually exclusive. So one of the things for us, and we'll talk about this a little bit in terms of our partnerships, is we don't see flash in the server as being something that excludes the use of flash in other parts of the infrastructure. In fact,
win if it's everywhere.
Yeah, well, the most important thing is do what's right for your situation. So FlashSoft Software is host-based solid-state caching. We run inside the operating system, inside the hypervisor, okay? As I mentioned, we are platform independent. The core caching engine itself is platform independent code. So it's deployed onto bare metal Windows servers, bare metal Linux environments, as well as into VMware vSphere today. So, and believe me, they're
I'm on divided attention now.
So, and Howard, we're still waiting for you to get your copy. So, okay. In a single node environment, the cache can be used as a write-back or as a write-through cache. So in a single server, we do provide write-back caching capability, which in many cases delivers significant performance differentials. Now, we'll talk. We'll talk. It is scalable to support literally hundreds of virtual machines or hundreds of volumes, okay? So you can literally select which volumes are to be accelerated and choose those volumes or those VMDKs for acceleration while leaving others unaccelerated. It's extremely resource efficient. This is one of the key things that we emphasize, is that the operation of the cache does not overly tax the system memory or the CPU. And we do that through, well, some very interesting things that Sergey is going to dive into. In our testing on Linux and Windows Server, you know, OLTP database acceleration, everybody's workload is going to vary, so we'll see different variants, but what's typical is a 3x to 5x acceleration in a typically IO-constrained workload. Batch processes, we reduce batch processing time, typically 4x to 5x. There are many databases that introduce latency unnecessarily, and those are accelerated even better. So, with VMware vSphere, similar results. Typical application performance is increased by 3x to 5x. Also, virtual machine density, we'll dive into the spec virt test results, but we see greater than 3 times the number of VMs supported on the same physical host when the virtual machine environment's accelerated. And again, the compatibility is a big thing for us. We are transparent to the applications and the operating systems above, and we are fully compatible with the storage systems below. The software runs only, we'll dive in a little bit more on this with VMware, but it runs exclusively inside the kernel of the hypervisor. There is no agent software installed in the VMs. There's no hooks to some external management controller. There's nothing that depends on what storage infrastructure that you're running. And we'll go into the details on that.
So it's not bare metal, it's only for hypervisors then?
No. In a VMware environment,
right,
we run in the kernel of the hypervisor as a loadable module.
So how is it OS agnostic? So does it run on bare metal?
Yes. In the Windows Server environment, we're a block-level filter driver.
Okay.
And we're a kernel module inside Linux.
Gotcha.
So
Okay.
it could work for Hyper-V as well?
And that's something we'd love to talk with you about.
We'll get there, right?
More teasers.
Yeah, stay tuned, next week. A few of our partnerships. SanDisk as a company is a strong partner to a variety of different companies in the industry, and we've continued that. Now, we are collaborating with NetApp to ensure the compatibility of our technology with NetApp's ONTAP stack. SCSK is our distributor in Japan. Virident is a partner of ours. We've announced that publicly as of last summer, in fact, that we're going and supporting our mutual customers hand in hand to provide them with a caching solution that runs on the Virident hardware platform, and that's been very successful for both companies. And of course, we are a VMware partner at a number of different levels. We are a VMware technology partner. Dell, we are working with Dell to make our products available through Dell's software and peripherals program so that Dell can provide it to their customers as well. So when we talk about customer use cases, the first thing I'll dive into is that we really see two use cases, two environments that are particularly I/O constrained, where the implementation of Flash in the server is a good idea. And these are obviously databases running in bare metal environments and virtualization environments. So in bare metal acceleration, speaking with people in financial services, telco, logistics, online applications, what we see is in transactional performance, we're able to deliver significant application acceleration. Average query response time, really, again, depending on the workload and depending on how I/O constrained it is, 3x is easily achievable. If it's a particularly bottlenecked workload, we've seen up to 20x increase in query response time. In environments where batch performance is a critical thing, this is something we see in the analytics applications that are run by our financial services customers doing overnight reconciliation processes, for example. The reduction of batch processing time is a very critical metric for them on very large amounts of data across hundreds of volumes. And those processes we're able to shrink typically 4, 5, or 6x. And lastly, just database workload. Many databases, quite simply, CPUs are underutilized. We're simply not serving enough concurrent users, so we're going out and buying ourselves another server, when in fact we should be getting fuller utilization out of our existing hardware environment. And we're able to basically triple or quadruple the number of concurrent users accessing a database within the same acceptable service level agreement. So when we talk about what the customers are looking for in server-side flash-based caching, these are typically the types of problems that they're trying to solve in bare metal environments on Windows Server and on Linux. With VMware vSphere, the customers basically have the apps that they've already successfully virtualized. And for them, the value proposition of server-side caching is that they'll be able to increase their VM density. So they're already within their SLA, but they'd like to be able to put more VMs per physical host. Server-side caching can remove latency that enables them to do that. Typically, what we see is 3x or more increase in VM density possible at the same level of performance. So for the applications where you've already done virtualization, that's the benefit. For the applications where organizations have been reluctant to virtualize, the so-called Tier 1 applications, we provide a way to realize the levels of performance that enable them to consider virtualizing Tier 1 apps. And SanDisk is a bit of it. We're a highly virtualized IT environment. We are a Fortune 500 company. We're a pretty serious VMware customer. We've been eating our own dog food for some time now. So we've been implementing FlashSoft within SanDisk and running applications like SAP on it, on VMware. And lastly, VDI. The same benefits. We don't, certain application architectures don't lend themselves well to VDI. Howard, you're smiling already.
It's just an evil smile.
And yeah, and I know why. But in a number of environments, we've been able to have an impact on the density of desktops as well as servers. I'll dive in for just a few moments on the economics of server-side caching, what it is we're looking at, because one of the things that we've encountered, I understand I'm talking to a very experienced group of people here, but one of the things that we've encountered is quite often our customers actually miss the economic side of caching. Focusing only on performance, sometimes they make mistakes, sometimes overspending on an acceleration solution when they've got spending more than they need to. So flash and servers today, we think, well, there's all SSD storage, which is nice, but it's expensive and isolates the data on an island. We could manually assign hot data to SSDs, which in databases can be tricky. It's labor intensive. It does give the results with fewer flash resources allocated per server, but it's labor intensive, and that labor can actually be more costly than the price of the SSDs themselves. And you're never quite sure if you've done it right, was one of the things that we've discovered. And then finally, server-adjacent SSDs, which we're seeing increasingly implemented, and those give a certain amount of flexibility because you can direct the performance of the SSD to the servers where it's required. The challenge, of course, is now you've put the performance of your flash behind the latency of a network of some kind, and so you don't get the full benefit of the flash necessarily. So based on what we've seen and what our customers have been thinking about, when they say, well, this is my wish list, this is what a cache needs to be able to do for us. Obviously, it needs to be cost-effective. It needs to give me a cost-effective use of my flash resources. It has to be completely compatible with my existing storage systems and practices. The sort of buzz phrase that we commonly hear is, I don't want to change my storage one bit, I just want to have it run faster. And that's essentially what server-side caching has the potential to deliver. This is extremely important because our customers, many of them actually have the resources to deploy all flash storage in the server, but they can't do it not because of the cost, but because of the business policies surrounding how they're going to manage their data. Their storage system has become the system of record for how they comply with federal regulations, how they manage co-location and disaster recovery, how they back up, everything. So they're not going to touch their storage systems, but they want the storage systems to run faster, and they look to server-side caching to deliver that performance without touching their existing storage investments. Secondly, caching needs to be automatic. You have to be able to set it and forget it. If you have to go back and tinker with it, then it's not a solution for many of our customers, especially in VMware environments. We're talking with VMware customers that are looking for solutions that will run across thousands of hypervisors supporting tens of thousands of virtual machines. So these things have to be deployed by policy, not by hand. And then high availability, obviously no risk to high availability. We're not going to sacrifice that in order to deliver server-side caching, and no increased risk of data loss. So that's what our customers are asking us for. That's their experience, and that's their wish list. So let's dive in and look at the economics of the architecture. Fundamentally, the purpose of a server-side cache is simply to bring the CPU to full utilization. And when I talk about people overspending on solutions, this is the thing. They overspend by implementing a cache in an instance where the workload is not I/O constrained, but is CPU constrained. A server-side cache will not benefit a workload if the CPU is already being fully utilized, okay? So we have to target where we deploy these technologies. We have to identify the I/O constrained workloads. Now in a VMware environment, that's usually rather straightforward, but we have seen instances where people have misdiagnosed the root cause of their performance issues and tried to throw flash at a problem when flash won't help, okay? It may seem trivial, but frankly, we have seen it. But again, another sort of corollary to this is that you only want to deploy as much flash-based caching as you need. Once you bring your CPU close to 100% virtualization, buying a larger flash device, buying faster flash isn't going to resolve the issue. So if we're talking about mid-tier servers, you may find yourself doing perfectly well with mid-tier flash. You don't necessarily need to put a flash device into the server that costs more than the server in order to deliver the performance benefit. And so what we do is we work with our customers to diagnose the degree of flash that they need to deploy, both in terms of capacity and in terms of performance, so that you spend intelligently. And this is one of the keys to having an all software-based technology, is we are able to work with them to help them identify the flash that's most appropriate to their requirements, even if it's not sold by SanDisk. So efficient use of memory, I talked earlier. There are a number of folks that have said, well, you know what's really great is if we can use some of the system memory as part of the cache, the so-called hybrid cache designs that may use flash and may use system memory. Especially in VMware environments, we find that stealing system memory in order to provide greater performance to the storage cache is a little bit like stealing from Peter to pay Paul. Your VMs want that memory, and we want to make sure that they get it. Also, in your database environments, well, guess what? Your database comes with a cache that runs in system memory. So why not use that cache first and use the flash for the storage caching capability, okay? Efficient use of the SSD. This is actually very important. There are a number of approaches to caching, especially for VMware, that recommend a static allocation of cache space per VMDK. And that approach, well, if the VMDK is idle, that cache space is not being fully utilized. So what we've done is we've looked at ways to develop a cache that's dynamically allocated to the I/O that requires it at whatever VMDK it might be serving. So dynamic allocation of the flash resource is very important. Again, the flash resource is one of the most expensive components in this accelerated server environment. We want to make sure that it's being fully utilized and you're not spending money on a very expensive piece of memory and then letting it sit idle or hold cold data. Storage efficiency, again, sort of the counterpoint to the objective of full CPU utilization is we want to see IOs moving off the SAN, okay? Because when you look at the fully loaded cost of a server, a significant portion of it is actually the cost of the storage that's underlying the server. And so what we want to do is we want to be able to take 80%, sometimes more than 90% of the I/O that would be traversing the SAN and hitting your storage infrastructure, and we want to take that I/O and we want to have it hitting the cache in the server. Okay? So you're not only delivering a more powerful server, but you're also relieving the storage infrastructure of an enormous amount of the overhead that is the very, very expensive piece of your IT infrastructure. And so by taking I/Os off the SAN, moving it into the server, running against the cache, and it's very important that we do this right by flushing efficiently, we're able to actually deliver more value out of our customers' existing storage investments. Okay? And lastly, again, back to the message of compatibility. This all has to be implemented in a way that works with existing applications and operating systems and works with the existing storage and server infrastructure. Okay. This is a small scenario, just doing the math on 12 servers deployed without FlashSoft. Those servers become more expensive when you deploy them with a flash device and caching software. So your purchase price per server goes up and you have more expensive servers. But what you find is the storage overhead is reduced. The storage overhead in OpEx and CapEx both. And so your net cost, your TCO, over a period of time can actually be reduced when you deploy more powerful servers. And again, this goes to the heart of our message, which is flash-based caching is not just about delivering greater performance, it's also about delivering a more cost-effective infrastructure in the data center. This is really what we see happening, and this is why we are so excited about these technologies that enable the intelligent use of flash. because they're going to change the cost dynamics in both bare metal and virtualized environments.
So you're saying the 12 servers with Flash and the software licenses for your product is in the 60K range?
No, because that's 12 servers, right? So what we did was we just assumed, and again, you know, what people pay on the street for Flash devices and even for our software, depending on who they buy it through, that will vary. So we'll dive in and we can talk MSRPs. But the servers with Flash, what we did was we uplifted each of them by $5,000. So we took a $10,000 server, made it a $15,000 server that was Flash enabled. So the same $10,000 server with $5,000 split across the cost of the SSD and the software.
Okay, that's what I was saying.
Yeah.
So $5 grand up is the difference.
Yeah, exactly. I'm sorry.
How much is that software license?
Somewhere within $5 grand.
I'm happy. I'm
The fact that, you know,
I'm happy to-
it's
I'm-
15 grand.
I'm
you
happy.
know,
Oh,
it's
no, no.
kinda like-
There's no.
Unless it's negative 10 grand, in which case I'm really happy. That's a great price.
Our announced MSRPs are not secret. We're not in stealth mode. We're selling product today. So for VMware vSphere, the product is licensed per server. In all cases, it's per server. It's not per number of, you know, CPUs or amount of memory or anything. We've all been through that, and we're glad we're done with it. But in the VMware vSphere product is $3,900 per server. These are MSRP numbers. Okay. For Linux, 3,500, and for Windows, 3,000.
Well, I mean, the point of the question was I was wondering how much of that $5 grand per server I had left over for the actual Flash device.
Yeah, yeah.
For $1 grand, that gives me an idea of what I'm buying.
Yeah.
For the hardware.
Well,
Yeah.
I just happened to be researching this because I knew this was going to come up. So for that 1,100 bucks roughly, you can get a 400 gig Intel DCS 3700 SSD, which is, you know, it's SATA, but it's a nice enterprise SSD.
Sure.
Yeah, and you know, it's going. The other thing about the price, and we'll dive into this a little bit later, is if you want redundancy in the SSD, you could put 2 SSDs, and we would support that. Treat it as a single logical volume. You could run them with RAID 1. So if one SSD fails, you don't lose data. Okay.
Like if you're in a write-back mode?
Yeah, in write back. Yeah. So you know, if we can see it as a logical volume, we can use it as a cache.
Sure.
So in that case, you may spend slightly more per server.
Yeah, no, that makes sense.
Yeah.
Thank you.
Mm-hmm.